Okay, so what we're doing today is more with solving equations. But what we end up having is a couple of special cases. So these are kind of not normal cases. So normally when we solve our equations in Algebra 1, you get just one answer, x equals 3, or x equals 5, or x equals -10. But what we're going to look at today is sometimes we get an equation that has just one solution, or no solution, or it might have infinite solutions. Okay, so that's what we're going to be taking a look at today. So it's still the same, we are still solving equations the exact same way that we've been solving equations all along. It's just these are a few kind of unique cases that we get. Alright, so sometimes an equation has more than one solution, or 0 solutions, or sorry, I guess I should say, or no solution at all. Okay, so sometimes we have one solution, normally, most of the time we have one solution. But sometimes we have no solutions or more than one solution. Okay, so if all the x's cancel out, what do I mean by that when I say cancel out? What do I mean when I say the x's cancel out?
There's no x, there's no variable.
Yeah, there's no x left over. X minus x is 0, there's 0 x's, so there's no variable anymore. So as you solve the equation, if all the x's cancel out, then you have one of these special cases. So if all the variables cancel out and your statement is true, put a circle around that word true, then your answer is all real numbers.
How do you know what that is?
What's that?
It is just like, we had to learn what it is irrational, rational.
Yeah, so those are the different classifications of numbers. We operate in the real number system, so we don't deal with imaginary numbers until you get to Algebra 2. And so what this is saying is it's every single possible value in real numbers. So like 0, 0.2, -0.5, 1/2, square root of 52. All of those would work in the equation. So we have infinite solutions. Everything works.
Oh, so it's like every...
Like every single number that you've ever known would work in that equation. Alright, so if all the variables cancel out and your statement is true, then we have our answers all real numbers. And we like to write this, instead of having to write out all real numbers, we have a notation for that. It's like this fancy R. It's like a capital R with an extra leg. So go ahead and write that down, because you can write that instead of having to write out in words all real numbers. Okay? And so when we have this happens, that means the equation is true for every possible value. And so, like I was just saying to Eric, that means every single number that you've ever said or heard of your entire life would work. We have another chunk of numbers called the imaginary numbers, but we don't deal with that until Algebra 2 and above. So far, any number you've ever heard of, like 1/2, 2/3, 0.3, 0.265, pi, square root of 52, those would all work in these. Okay, so when we write this in set builder notation, we do this table, and assuming our variable is x, then we would write x such that, and we're going to say x, and then we have this kind of weird looking e thing, and then our capital. So what this reads, it says x such that x belongs to the real. So it means x is every single value in the real numbers. This is just a weird looking e that it's a symbol we use to mean belongs to.
Can we do that something?
It's just like a C with a line.
Right. The real number.
Oh, just do a capital R and put an extra bar next to it. That's what I think. Okay, so this is what happens when you have no x's left and your statement is true. So like an example would be is if we get 5 equals 5. That's a true statement. Then we know that we have all real solutions, all real numbers. But if the variables cancel out and your statement is false, then it is no solution. Then it is no solution. That means the equation is not true for any value. So no matter what you put in, it won't work. It's not true for anything. And you should be needing your calculator right now here. All right, so when we write this in set builder notation, we have a couple of options. We can go ahead and we have what's called the empty set, where you literally just draw your curly braces and write nothing in it. That means nothing works in it. And then we also have another way we could write it is we draw curly braces and we put that here. Has anyone seen this symbol before?
Uno.
Okay, yes, it could look like a zero to no. What this means is no solution. We call this the null set. You don't have to remember that. But, so you can either write it with an empty curly brace, that means there's no solution, nothing works, or this symbol here actually means no solution. You want to, it's up to you which one you want to write, but you want to make sure you're familiar with both, because on the SQL they could present it in either way. Okay, so if it's true, all real numbers. If it's false, no solution. So an example would be if it said 4 equals 5. Does 4 equal 5? No, it never equals 5. So we have no solution there. So let's go ahead and take a look at a couple examples of this. So then we're solving just like we've solved all along. It's just now we didn't show you guys these crazy examples because we didn't want to confuse you at first when we were learning how to solve. But now that we've had practice solving over and over and over again, we're going to take a look at these. All right, so for example, we have x plus 2 equals x minus 4. So remember, we want to get the x's on one side and our numbers on the other side. So if I have x plus 2, how do I get rid of that positive 2? What do I do? Subtract 2, good.
You're gonna subtract it out of negative
2, subtract 2.
You get negative 6.
So I get x equals x minus 6. And we want to get our x's on the other side. So if I have a positive 1x, what do I do to get that to the other side? Subtract. Good. So subtract my x. What's x minus x? 0. X minus x is 0, and we still have our negative 6. Does 0 equal negative 6? No. So this is a no solution.
Oh.
Right? This is false. So notice there are no variables left. They canceled out. And we have a leftover false statement. It's no solution.
That's because 1x minus 1x is x.
Yeah, so like if you look at our original equation, x plus 2 equals x minus 4, there's no number I can put in here. Like say I put in 5 plus 2 is 7, 5 minus 4 is 1. You're never going to get the same thing on both sides.
How about if you have would it ever give us like a negative x?
It could, but remember it's going to be the same value. So let's say it was like negative 2. Negative 2 plus 2 is 0. Negative 2 minus 4 is negative 6. It's still going to give you two different values every single time. So what we have is we're starting off with the same number, but then I'm adding 2 to one of them, and I'm subtracting 4 together. So if you're adding 2, but then subtracting 4, you're not going to get the same value. Now here specifically didn't ask for set builder notation. Let's suppose it did. And our answer, I like to do the no solution one. Maybe that. So that was a little bit easier to see from the beginning. But let's go and take a look at our next example. And let's go and distribute that 3.
3 times 12. 3 times 4 is 12.
3 times 4 is 12. 3
3
times 4 is 12x. It's 12x plus 12. Ooh. What do you guys want to do here?
Minus 12.
Yeah, let's go and subtract our 12.
Does it matter where you minus the 12 from? No.
Well, I mean, as long as it's from the number and not the
We
x.
both cancel out.
So that cancels, we're left with 12x equals 12x. And that cancels.
Divide.
Sure, we can divide by 12. 12 divided by 12 is 1x. Is 1x.
All real numbers.
All real numbers, it's the exact same thing, right? And if we take a look up here, Wasn't that the exact same thing? 12 plus 12x, 12x plus 12, those are the same thing. You could even go further here if you wanted to. And you could say, okay, well, let me get rid of my x. Subtract x, subtract x. You're still going to get 0 equals 0. So we have a true statement, it's the exact same thing, but we have no x's left. But it's a true statement, 0 equals 0. So our answer is all real numbers. I'm again going to write this in set builder. So we have x, weird looking CE combination, all real numbers.
So that's how we would write it if.
And set builder notation. Yeah, so this means belongs to. So x belongs to the real number. So x is a real number as opposed to imaginary numbers. So these are the type of situations we have. False statement, no solution. True statement, all real solution. What if I get x equals 5? What does that mean?
No solution.
That's your solution, x equals 5. Right, that's the normal thing. So don't forget, we can actually get answers. Most of the time we'll get answers. But every now and then you have a no solution or all real numbers.
Oh, so we're still gonna get those questions where we distribute everything to get x equals 5.
Yeah. Yeah. Those didn't go away. Alright, so solve following equations and write your answer in set builder notation. Okay, so this is just what we were doing before. I'm going to go ahead and combine my like terms.
7 minus 4.
Good, we can combine our 7
3m.
minus 4, and that gives us 3m minus 1. Can I combine anything on the right side?
Yeah, you can minus 3m thing.
Well, before, like, just simplifying
Oh,
here.
yeah. You can 8 minus 9.
Good, 8 and
Negative
minus
1.
1. So we have, what would that be? Negative 1, and then it's still a constant.
No, we gotta move the variable to the other side.
Okay, let's move the variable to the other side.
So minus 3.
We get negative 1 equals negative 1. Notice our variables have disappeared. Is this a true statement? Does negative 1 equal negative 1?
Yes.
Yes. All real numbers. So again, it's set to write it in set builder notation.
Wait, so you wouldn't get rid of those other numbers like before the variable? 'Cause,
You can if you want to.
like you wouldn't get rid of negative 1 stuff like
You
plus 1
could.
plus 1.
You could say plus 1, and then you get 0 equals 0. That's
Oh,
fine.
yeah.
So it doesn't matter. Once you get rid of your variables, you can stop as long as you have either a true statement or false statement. And so, like, suppose you stopped here at negative 1 equals negative 1. Someone else could have kept going and had 0 equals 0. That still shows it's a true statement. It's still going to have the same answer in all real numbers.
Okay.
All right, so we have x such that x belongs to the real number.
What did we write?
Yes! Who said that? Who was that? Good work, Joanna, right? Good work, Joanna. It's an M, isn't it?
Oh, nah.
Oh, sure.
It's an M. Oh, man. Good work.
So he's using it.
I know. Check this out here. Maybe M represents the number of monkeys that eat bananas. I don't know. This is the first M word that came to my mind. Okay, let's go ahead and take a look at number 2. We have to distribute. What's negative 2 times 6?
Negative 2 times 6 is negative 4.
Negative 12.
Negative 2 times negative 10 is negative 20. No, 20.
Positive 20.
Negative.
And again, guys, something that I've seen when I've been creating your guys' mini quizzes and tests is that we use negatives along the way. So use a calculator to help you out. It's negative times negative, this is positive.
See, that's the thing. Like it slips out all the time. Like when it says negative 6 minus 10, I always think it's still a positive 10,
But it's not.
but it's not. Yeah, that's.
Alright, and then here we have 10 times 2x is 20x. 10 times negative 6 gives me negative 6.
Equals 10 to 8. So.
So again, either get your numbers on one side first or your x's on one side. It's totally up to you. What would you guys like to do? Subtract the 20x. Okay. So minus 20x. Alright, so over here I have negative 12. Those cancel. Oh, these ones cancel as well. Ooh, our x's are gone. Thank
This
you.
is not a real number.
Nope, go and give it to me. Give it back to Pennypass. Is this a true statement? No, it is false. So what's our answer?
No solution.
No solution. Is that even? No solution. Okay, questions with that? Alright. Let's take a look at
But
that.
at the same time, I'd probably end up getting confused by if I see the other numbers after you're done distributing. What if I did like plus 60 to get rid of that negative 6?
You can do that. Here, let me show you.
Because I want to just like end up doing it and doing something wrong.
Alright. So you're saying, what if we did plus 60, right? Plus 60, plus 60. So then what we have here would be 16 minus 12, which gives us 48, plus 20x equals 20x, and those cancel, right? So we'd want to get our x's on the same side, so then we would subtract our 20x, subtract our 20x, so we have 48 equals 0. Still a false statement. You see?
Wait, so it doesn't matter. So the numbers we get doesn't matter. You want to know if it's a true or not.
Exactly.
That's the answer.
Once your x's disappear,
You can stop there.
you can stop there and then decide is it a true or false.
Oh, so that's what the answer basically is, if it's a true or false statement.
Yes, but true means
You don't know.
all real numbers and false means no
No
solution.
solution.
Did you have a question? Let's go take a look at the back side. Of course, we have to have fractions, right? Ooh. Alright. So we can either distribute or we can multiply to get rid of it. I'm going to. What do you guys want to do? Distribute? Distribute? Okay.
Wait, how would you get rid of it?
So if I wanted to get rid of it, I have 1/3. So I would multiply by the flip. We call it the reciprocal. And I would do that on both sides. But that sometimes gets a little complicated, so usually distributing is a little bit easier.
Yeah, pretty much.
Alright, so let's distribute.
1/3 times 6 is 2.
Very good. 2a, don't lose our a. Anyone know what 1/3 times positive that is? 3. 3, very good. So positive 3. If I have 6 cookies and I cut them in half, how many do I have?
3.
3. And now we only have 4 cookies divided into 2. Does anyone notice something sneaky about this equation right here? It has the same stuff, right? 2a, 2a, 3,
So-
3.
Doesn't that give it away already? That's going to be all the numbers. Yeah.
Now, do me a favor, because sometimes they'll make there be little negatives in there that might trip you up. So at least go ahead and get rid of your variables. Okay, so just to make sure we're looking at it correctly, let's get rid of our variables. And double check that there wasn't anything sneaky with it.
2a is.
3 equals 3. All real numbers.
So let's say if there's no variables or anything, no variables. If there's no negative signs or anything, and it has that type of thing, the same thing on both sides.
You can automatically say all real numbers. Because what that is it's a true statement no matter what. A belonging to the real numbers. Ooh, number 4, they're trying to be tricky here.
2 times a is 2a.
Good. 2a. 2 times -4.
Negative 8.
Negative. Now this is where they're trying to be sneaky. I have 4a. Am I distributing 4a? No.
No, you
No.
gotta add a 1 next to the negative.
Good. This is -1 that I'm distributing. What's negative 1 times 2? Negative 2a. And negative 1 times 4? Negative 4. Alright, I want you guys to solve it now.
We combine like terms also, right?
Mhm.
This type of thing.
Yeah, so I would say go ahead and combine your 4a
So 4
and
minus
negative
2.
2a.
Would that be 4 minus? It would be 4 minus 2.
4 minus 2. Two a and negative 8. Does negative have an
If it's
a
a false
with it?
statement, miss, is it a no solution?
If it doesn't have an a with it, we can't combine it, can we? They stay as two separate. Alright, let's take a look and see. So if you guys get 2a minus a equals 2a minus 4. And it does end up being no solution when I subtract away my 2 a's. We get negative 8 equals negative 4, and that is not true. We're doing a's again? Okay. Oh, it's a no solution. We're just going to draw that fun little circle with the line through it. What's that? Yeah, you could have subtracted 2a from here as well. Alright, do we have questions on 3 or 4?
It's the same thing, right?
Yeah, it's just more and more practice with that. I'm hoping that we'll get an actual answer somewhere.
Ooh, 7 and 8 between
Ooh,
the fraction bars.
let's do 7. So we've got a fraction equal to a fraction. Who remembers how we solve this? Well, yes, cross multiply. Now the key thing when we cross multiply is I like to go and put parentheses around anything that is more than 1/3. So when I cross multiply, I'm going to do 4 times x plus 1. And I need to put those parentheses there.
Then 2 parentheses times 2x.
Good.
Oh, so this is a way to get it to distribute, right?
Yes. There is another way you can solve this, but it's much easier just to cross multiply.
4x.
So we have 4x. Is it 4x plus what?
Bro, it's the same.
No, 4x.
4x plus 4. Good. And over here, what? Did you say we get the same thing?
Yes.
So again, at this point, it looks like it's all real numbers. I'm just going to go and subtract away my 4x's just to make sure I'm not seeing things. Oh, and 4 equals 4 all the time. Back to the x's. X belongs to the real numbers. So similar with number 8 here. Put those parentheses around. Alright, so go ahead and cross multiply. So I want you guys to try this one. I'll come around and answer questions for those that have questions. I want you to try this one.
So no solution.
So it's in 4 times 3. So it's in 3 times. And 18%. And now, times 4.66. So is that 69 and this? And that So we're getting 45 times 100 times 13. You were thinking ahead. Yeah, because it's positive. That looks good so far. That looks good. And then hit the clear. And then see how it's positive. Yeah, you want to subtract. First, let's get rid of the rest. Subtract
And you turn the drop to 300.
It's 49.
Okay, so let's take a look at number 8. You guys are doing really well setting this up. So again, when I cross multiply, so I've got, alright, so my yellow, I have 9 times x minus 5. My green equals are 3 times 3x plus 3 squared. So that's my cross multiply. You guys are doing really well with that. So when we distribute this, I get 9x minus 45. And over here we get 9x plus 45. And again, let's go ahead and get rid of our x's first.
And negative 45 equals 45. So.
Negative 45 equals 45. Now, depending on how you did it, you might have moved your 45 over and got 0 equals 90. It's still a false statement. So our answer is squiggle, no solution, squiggle. Okay, so again, depending on how you solved it, you might have gotten 0 equals 90. It's still a false solution or false statement, so then our answer is
I'd rather do these equations.
I know they're kind of nice, aren't they? You stop really fast. Okay, let's go back up to these ones up here. We don't want to deny 5 and 6. Okay, number 5. What do we do with this negative sign in front? Yeah, we have to distribute that negative 1. So I have negative 1 times 8 is negative 8n. Negative 1 times negative 2.
Positive 2.
Positive 2. Good. And am I going to have 7 here? Is it 7 times that? 13? Is it 13? Is this what I do?
Yeah.
Hmm.
So you gotta distribute first.
We have to distribute first. Yeah, we have to distribute first.
So it'd be 10.
So it's a positive 10 times positive 1, so we still have our 3 signifier. Then positive 10 times positive 1 is positive 10. Positive 10 times negative 3
It's -3.
negative 30. Okay, so again, we have to distribute first, because if we think of our gem dots,
The grouping symbols are always first.
yep, but technically we're actually multiplying here. So multiplying comes before the x.
Oh.
So, I mean, same idea.
So then you could do.
Yeah, let's go and combine our like terms. Now we can go and combine our like terms and we get 13 minus 30m. Okay, I think we might actually get an answer this time. How exciting! Okay, so let's try to get rid of our variables first. What do you guys want to do? Add 8 or do you want to add 30? Alright, let's do it. Ooh, what's negative 8 plus 30?
22.
22 and you spell plus 2.
2 equals 30.
So it's 13 and this gets
Now get rid of the 2.
good. How do I get rid of 2?
Minus 2.
Good,
Minus
subtract
up
2.
to the 32. You get 11.
22n equals 11. Ooh, now what do we do? Good, divide by 22.
Get negative 11.
Negative 11?
Whoa.
Positive 11, right?
That works.
You okay? Alright, so we get n equals
Divide.
1.
Can we put it in decimal form also?
Yeah, that would be fine. Put in decimal form because it stops, right? It's only 0.5, nothing else. Alright, just in case they ask for a set builder, n such that n equals 1. So this is an actual solution, one solution. Alright, number 6. Oh man, they gave some fractions. Well, let's go ahead and get our, there's no distributing to do. Let's go ahead and get our x's on the same side. So by the positive 2/3, positive 1/3, I'm gonna have to subtract to get rid of it. Which one do you guys want to subtract? 1/3? Alright, so subtract 1/3 x. Now again, be careful when you type this into your calculator. Either put parentheses or use the vertical fraction. Who remembers how to get to the vertical fraction?
U alpha y equals.
Good. So alpha y equals.
You get 1/3 either way.
Okay. Now, if you don't do that, you're going to have to instead use parentheses. 2 divided by 3 minus parentheses 1 divided by 3. But if you use that vertical fraction, you don't have to worry about parentheses. And we get trace decimal, math, frac, 1/3.
Hold on. Now you would 1/3 plus 20 equals 20 equals 20.
So we have 1/3 x plus 20 equals 20.
You want to get rid of the 20.
Get rid of our 20, okay, so subtract 20. 1/3 x equals 0. Now we still have an x, don't we?
Yeah.
So we can keep solving. We haven't gotten rid of our x's. So if I have 1/3 times x, how do I get rid of that 1/3?
Divide.
Yeah, flip it. So multiply by 3/1. That's the same thing as dividing by 1/3. A lot of people get that confused. So over here we just get x. What's 0 times 3/1? 0. So what do we have here? Is that a solution, no solution, or all
One
solution?
solution.
Yeah, it's one solution. We can have an answer of 0, right? It's an actual
Well,
answer. There's an actual value.
But doesn't x by itself equal 1?
Yeah, so 1x equals 0. Just like over here, 1n equals 1/2. It's an actual answer. Our answer is 0. 0 is what makes this true.
You know what I just remembered?
What's that?
What class the smart board has been getting ready for?
I know, isn't it wonderful?
What do you think?
I think it might still squiggle somewhere within here. Oh no, no, it's perfect. Yeah, let's hope it continues.
Oof.
Questions about that? It's not bad, right? So we're just solving equations like normal. The only new thing is that
Two new answers we could get.
if you don't get a nice normal answer, you might get no solution for all these. Okay, questions with that? Got your homework tonight? It's just more of this, solving, and you'll get some special basics like that. It's nothing there. I'm so proud of you. That way you get to stop playing Mario Kart.
Yo, everyone's on that game.
No, my sister doesn't.
That's gonna be the new
Takes up so much
Pokemon Go.
battery and data.
Yeah, it uses up a lot of data.
I don't
I downloaded it and it took up like 3 gigabytes of data.
just download.
Just downloading it, because you have to.
I have 64 gigabytes in my phone.
No, I'm not talking about the storage on your phone. I'm talking about your data plan. Usually, like, well, at least my company, having unlimited data after 50 gigabytes, it slows down your network.
Yeah.
So, I was just at the verge of 44 gigabytes out of 50, and I downloaded it, and I only have like, I'm like at 49 now. I'm gonna try to use my phone, I don't want to be slow.
Is there anyone that did not get the homework? I think we're still working on it.
I know for sure.
Thank you, Alessandro, for staying on top of it. All right, if you guys would go ahead and return your calculators, erase your name up off the board.